Sorry about that, Neil.
Hello, we're on, right. Thanks everybody. We'll start off with a quick slide on the Samtec business model, who we are. Basically, we're split into sort of two halves of the business groups. Core board to board is our first generation of products, Core Era 1 we call it, which is rugged power, pin headers, early cable assemblies. The silicon to silicon, it develops further in towards the high-speed world of high-speed board-to-board optics, high-speed cables, and RF, where we're developing systems that really get us from 10 gigabits, 100 gigabits Ethernet, right up to PCI Gen 5, Gen 6 series. As a global support company, anything in the orange is one of our design centers head offices. As you can see, we're split mainly across the US and Taiwan, Japan from a design point of view. Manufacturing, we are America and Asia, sales offices all over the world. So there's a big global presence. Number of employees, 6,500, 7,000 employees total worldwide. Lots of sales support, sales offices, and design centers available, all for, say, supporting customers on different product groups. How do we go to market and support customers? So, we've got various tools online, solutionators, picture search, 3D models. The idea of the solutionator is to give you a quick pictorial view of how to select a connector cable system via a visual tool, and easily set up a part number, download models, etc. The picture search gives you another view of how to get things done. And then 3D models. Once you've then created the part number you're looking for, there's usually a tool there that enables you to download 3D models, different formats for your upload into your tools. So the solutionator, this gives you an idea of where you can start from arrays, dual row strips, edge card, backplane, physically looking at the products, and then you can drill down within there to numbers of pins, mated stack heights, processing types, whether it's surface mount, through hole, etc. And it's a very intuitive way of being able to define a part number visually, get down your models, technical information, order samples, which are usually free of charge. And internally, when we look at our product groups, high-speed board-to-board, high-speed cable, rugged power, flex stack, optics, RF, these are our main groups internally, how we segment our products. High-speed board-to-board, typically getting up to 112 gigabits per second data rates today, dual row strips up to full 800-pin array systems. High-speed cable, everything blue on this list that we can see here, drawing here, is based on a twin-ax or coax technology. It's part of our IP, how we manufacture this, and they're very good up to 112 gig, 224 gig, very, very low loss transmission systems. Rugged power, part of our Core Era 1 product systems, doing a lot of ruggedization and ruggedization features, aligned to keeping parts on boards, under shock and vibe, etc. Flex stacking, I think we can build ASP part numbers in pin headers to plus or minus 0.13 millimeter stack heights, up to like 25 millimeters. Really flexible in how we get to solid stack heights. Optics, a fairly new product group for us, about 8 years old now. That gets us to mid-board optical transceivers, very widely used in the EDA, emulation, test measurement, and military aviation world. And finally, RF, very good for test points, our own 75 own BNC series, so in-house solutions, and also for test and SerDes testing. So looking at high-speed cables, really we're thinking inside the box. So everything from your... Sorry, the pointer. So everything here for these blue cables is running from your AI, FPGA, high-performance processor in the middle. And we're taking the high-speed lanes straight out to front panel, could be a QSFP DD, DD800, OSFP, or to a backplane. And the whole idea is, rather than putting your high-speed signals through your printed circuit board, you're flying them over to an I/O system. And that's helping you to improve your SI performance of the channel, whether you're governed by PCI, IEEE, OIF, VSR, and also enable you to optimize your PCB layout, which can be multi-layer boards, and streamline your PCB processes. So everything we do in terms of these high-speed cables really gets inside the box from your chip out to front panel or back panel. And this gives an idea of some of the data rates we can support on the right-hand side, 56 PAM4, 112 to 224, and whether we get to being a front panel I/O, near chip cable, co-packaged, mezzanine, etc. So what we're showing in the middle is the SciFly HD, which is a co-packaged system. It's the connector on package that goes straight out from the substrate into what would be, in this case, the OSFP front panel. So that's taking 16 twin-ax cables at up to 224 gig data rates straight from the package. We also do near-package designs where you're taking your signals out of the package, into the BGA, across a bit of PCB, straight into connector, out. It's all about streamlining your SI performance for reach and channel performance and bit errors. So depending on what your data rates are, 56 to 224, we've got different front panel systems, flyover, SFP, QSFP, QSFP-DD, DD800, OSFP, that then align with a connector of some kind for SI performance. And then we think about what can you place next to your chip, your package. So these are a number of the Accelerate, Novaray, and SciFly low profile. These are some of our high performance interconnects that have the direct attach of cable to contact for best SI performance, but it's vertical, right angle, 8 pairs upwards, aligned towards our front panel I/O systems and the high-speed twin-ax. So in the case of the Accelerate series here, this is what we call sort of small, fast, and cheap, because it's quite a miniature package. It's available as vertical, right angle, 8, 16, 24 pairs. It's great for 56 gig PAM4. So when you're looking at OIF, CEI, VSR 56G as a standard through the IEEE bodies, then we can build a system based on like an ARC6 to a QSFP front panel, look at the losses by the standard, and we can do some simulation work and demonstrate compliance. So Novaray gets us to the highest performance, purely based on differential pairs, up to 112 gig. And the SciFly system here is all about the lowest profile, down to sub 4 millimeters in right angle system off the board. Next to the chip enables you to do optimal cooling of the heat sinks on the packages. And this now shows us the heart of what's in these cable technology. So for the main purpose here, they're all based on a twin-ax design of 2 conductors in a dielectric with a twin shield and a jacket. Depending on the iteration of cable, we've gone from stranded cores to solid copper conductors, which improves the SI performance, doesn't affect the bending too much. We have a silver-plated aluminium conductor, and we're down at 34 wire gauges, is giving us our best performance inside the box to 112. We've got a new ultra-low skew 28 and 32 wire gauges, gets us to 224 wire gauge, 224 gigabits per second data rate and longer reach. So all these are proprietary cables from Samtec. There's also a coax cable as well. So we're doing 50 ohms single-ended based on some of our cables. We can now mix and match both differential pair and single-ended in the cable type. What we've also done is we see here a slight different jacket material on the outside. So due to change of material composition, manufacturing techniques, we now have what we call a wrap on these two, which gives us a size reduction on the outside, better for airflow. So the performance remains the same from an SI because the construction, the conductors, the jackets, the conductors, the shield, the dielectric does not change. It's just the jacket material. But we get a 40% size reduction without losing performance. And high-speed board-to-board. So I thought I'd start here, really, introducing what we call the Array series and the C-Array, because it's one of our biggest-selling flagship products in board-to-board. It's very flexible in what it does. And in most cases where customers talk array systems or need multiple I/Os and signal types, we start with the C-Array and work from there. So it's based on the C-Array is also the equivalent of the FMC Plus series. And we get different stack heights, 4 mil to 40 mil. It's on a 1.27 mil pitch. Other pitches available, different series, and we can get up to 560 pins. But we show here on the bottom side of the screen, we've got accelerate performance, Nova array, C array, different array types based on whether you want density, low stack height, or best performance. So a whole range of products available in the array series, depending on what you want to do. And this next image here gives the view of what you can really do with an array series as an open pin field, because no pin is defined for any particular function other than your pin mapping. So if you want to do differential pair, single-ended, analog single-ended, power, or just signals, you can define your pin assignments accordingly. So you can have a ground-ground, signal-signal, ground-ground mapping and do 25 gig Ethernet PCI Gen 5 through one portion of your interconnect. You could similarly have some single-ended pins going through your interconnect, or indeed, at the far end, you could put power. So we have a current count capacity chart that will allow us to look at and view how much current you can put across multiple pins in a socket. So it really gives you a lot of flexibility. And aside from the arrays, we go from pin pitches from 0.4 millimeters upwards in high-speed connectors, stack count down to 2 millimeters, dual row up to 14 rows. So most of our series will start at 2-row strips. It could be an edge rate or a Q series. The ultra micro gets us down to very, very low stack heights. We support edge card systems, which can be PCIe sockets up to Gen 5 speed, Gen 6 speed, as well as our HSEC8 high-speed edge cards on a 0.8 mil pitch. Really good, robust product. The right-hand side in high speed, we get backplane. So we've got a license with Examax Amphenol, so we do a dual sourcing agreement, intermatability, and we can also build a bunch of customs based on taking sub-modules for power, signal, I/O, based on this solar system here, the Exceed HD. So we've got a lot of customization available in high-speed systems. Thinking of RF, and really we've got both cable and board sockets. We go down to 1 millimeter, 1.85, 1.35, 2.4, up to 3.5 millimeter SMAs as test points. For those, we also mate with cable assemblies. We can mix and match cable types. We've got our own orange cable now, type called Nitrowave, which gets us up to 112 gig frequencies in RF. We come across to other cable types, including what we see here as Bullseye. And the Bullseyes are RF test points for doing SerDes testing. So if you're breaking out from FPGA and you come out the SerDes at 112 gig or 56 PAM4, we'll do a high-density test point going out to 2.92, 2.4 mil SMAs for SerDes testing. And this gives an idea of a view of one of our more recent products, the Magnum ganged RF series, which is great in applications of phased array antenna and quantum computing, where essentially you've got a board mount, either vertical, right angle, or edge mount SMPM gang system going out to cable. We can offer different detents, up to 8 ways as a standard product, including a screw attached for more harsh environments. But essentially, we get it to 65 gigahertz RF in a very, very small form factor solution. And at the launch side, coming out of the pins at the side here, isolation up better than 65 dB. So it's a really nice product in both strip line, microstrip. So Firefly optical modules, aside from the passive products, we've got an active series called Firefly. Now, these are midboard optical modules which are sat here and here. And this application board just shows the application of where they're used next to a core processor, so a big FPGA. And the essence is where you need to have very, very high density and very, very high performance signaling, up to 25 gigabits data rate, going to longer reach, the Firefly optical modules gets you midboard and very high density. So at this point of your faceplate here, each one of these MTPs is taking 24 fibers, 12 lanes. So if you compare that to what you would get through a QSFP-DD module, the physical size is far more dense than what you have elsewhere. So you're basically taking your high-speed lanes out of your FPGA, straight into optical module, out to fibre. And the series covers a copper ECUE Firefly. It covers the ECUO optical and the PCUO. So we can transport both Ethernet and PCIe over fibre. From an Ethernet point of view, we've got commercial, wide temperature minus 48 to 85, and a ETMO harsh environment for shock and vibe. In the PCIe side, we've launched a Gen 3 and Gen 4. Gen 5 will follow. So we'll have a 32 gig by 4 module and potentially a 32 gigabit by 12 module coming out in the future. And each of these modules, as you go through the series, from commercial temperature, wide temperature, to the military version, you can migrate through the series on the same pin mapping. You can then go up to the 25 gig series from the 12 gig series, a change of VCC, and all the lanes map OK. So there's a nice upgradability through the system, the Firefly, but essentially you're basically taking your optics from the front panel into the chip for density. Applications here, it's harsh environments. We're seeing military, aerospace, defense. We've got test equipment, EDA, and carriers. And finally, touching on rugged power. So remember, it's the heart of where Samtec came from many years ago. We have the Tiger Eye cable systems, IDC. We've got high power blades with mixed signal. We've got rugged I/O systems, rugged SI, where we're taking a harsh shock and vibe environment, and we're doing testing for up to 8 gigabits per second data rates with shielded connectors, cables, and other areas. Now, what are these rugged features that we need? So jack screws, positive latching, friction lots, all these are applied to many of our series that give us a more stability under shock environments, latching, retention pins, guidance, and so on. So in this case here, the shielding, we're adding a shield around the mating bodies. We can do that for a high-speed cable as well, where we pull the grounds in. Many of our products have got guideposts for better alignments, and again, weld tabs. So usually a -WT at the end, we'll put a weld tab in. That'll give better security on the board. So a lot of our series are including many of these retention features. In some cases, for edge card sockets, we've got board locks. So if you're doing edge card to edge card with a riser card in between, separate your boards, the board lock will hold it into one side and keep things secure for you. And then standoffs. So one of the things we see is when you're putting boards together, taking them apart, how do you align boards together? Well, we've got some guidance products for keeping boards aligned to avoid misalignment, broken pins. We've also got standoffs that create a mated stack height aligned towards the sockets themselves. They're all tooled up. So there's a whole bunch of hardware features, ruggedization, built into our general series that's available for most products. And then severe environment test. So we've had what we call an extended life product, ELP, for many years, where we put products through extended testing for nitrous acid, gas, etc., and shock and vibe. So we added the SCT, which is closely mapped to Vita 47 and Vita 42 testing, to a higher class of shock and vibe. The reason for this is it gets us more towards military environments without being MIL qualified. And it's proven very reliable in a lot of mil aerospace customers, where the SCT logo is applied to some of our series, the C array, edge rates, some of our cable assemblies. So if you see this anywhere, or you need an application for harsh products, then search for this and you'll find where you want to go. And just to finish off, we have a topic of what do we cover as support and where do you go? So before you get to a part number, you might end up with, you're going to need a mechanical stack height, orientation, vertical right angle. You might need cable length, mating cycles, processing technology. Where do you start with finding a part number? And from all these topics of pin mapping, current kind capacity, high-speed data protocols, pretty much you're going to find catalog page, prints, test reports, 3D models, and mechanical samples. All this is available for many of our series that we have available. Now, the further we go down the list, the more complex it gets and the higher speed we end up with. You get down to qualification notes, DVT, high-speed characterization reports. So we can create these as customization based on, say, PCI Gen 5, Ethernet 100 gigabits. And we can do simulations, S-parameter models to look at full channel analysis. So there's a whole bunch of extra supports we have outside of our creating part numbers. And then if we get to the optical side, we've got a whole different set of parameters altogether, where we're looking at link budgets, link mapping, fiber mapping. We're looking at SI-optimized breakout regions. We've got schematic checks, layout reviews. So we're now in the active world of how we support customers for a different type of system. With an optics, again, under NDA, we can support qualifications. We've got DVT, or data sheet design guides. So it becomes a far more complex challenge supporting optical modules over copper systems. But behind the scenes is all available to come and support from Samtec. There we are.
Thank you very much, Neil.